Currently, the night sky is undergoing significant shifts, ones that could drastically alter its appearance in the coming years, possibly even decades. Scientists and astronomers around the globe have sounded the alarm, with figures like Neil deGrasse Tyson expressing concern about the changes ahead. Experts have warned that Polaris, the North Star, is on the brink of an intense transformation, and the story behind this potential event is troubling. Polaris's position as a fixed point in the northern sky has long made it a symbol of stability, guiding sailors, astronomers, and travelers for centuries. However, this steadiness could soon face major disruption, which may have profound effects on both our understanding of the night sky and our cosmic measurements. Let's delve into the significance of this potential transformation and understand the implications for us all. Polaris, otherwise known as the North Star, has been a prominent feature of our night sky. Positioned near the celestial North Pole, it has maintained a stable position, seemingly fixed above Earth's northern pole. This fixed nature creates the illusion of a star that remains motionless in the sky, unlike other stars that move. Located in the constellation Ursa Minor, Polaris is a yellow-white supergiant star, standing out for its size when compared to our Sun. Despite appearing as a single star, Polaris is actually part of a complicated triple-star system, consisting of Polaris A, Polaris B, and a third companion star, Polaris C, which orbits the pair. The gravitational forces among these stars affect their movements and impact their luminosity, causing their brightness to fluctuate in response to their interactions. These forces can also result in irregular brightness patterns, depending on how these stars orbit one another. Polaris is about 323 light-years away from Earth, meaning the light we see from it today was emitted over 3 centuries ago. Therefore, if Polaris were to experience an explosive event, we wouldn't know about it until over 300 years later, when the light from such an event finally reaches Earth. Some scientists believe that Polaris may have already undergone such an explosion, but the light from that event has yet to reach us. Throughout history, Polaris has played a crucial role in human civilization. Its importance in navigation, symbolic meaning, and cultural significance are immeasurable. In ancient times, the star's position near the North Pole made it an invaluable tool for sailors, providing them with a consistent and reliable reference point for determining direction. While advancements in technology have reduced humanity's reliance on stellar navigation, Polaris still holds great symbolic weight, representing guidance, strength, and constancy across many cultures. In recent times, however, astronomers have noticed unusual behavior in Polaris. Previously, the star followed a predictable pulsation pattern, but lately, it has shown erratic dimming and brightening, indicating a possible change in its stellar life cycle. Researchers have raised concerns that this irregularity may suggest that the star is approaching the end of its existence. Such behavior is consistent with the final stages of stars before they burn out. Astronomers have noticed that the duration of Polaris's pulsations has increased by roughly 4.5 seconds, a change that may seem trivial but carries significant weight in the scientific community. The sky has long been a source of fascination and inspiration for humankind, and the idea of losing a steady celestial marker like Polaris raises concerns about how future navigation systems might be affected, particularly in cultures where stellar positions still serve as vital guides. Even though we have advanced beyond the need for reliance on the North Star for navigation, its disappearance would mark the end of a long era and a loss of an important cultural icon. Polaris's story is also a valuable case study for scientists studying the behavior of binary star systems. In this system, the primary stars, Polaris A and B, along with their distant companion, Polaris C, interact through gravitational forces that influence their motion and brightness. These interactions contribute to the irregular pulsations observed in the star's luminosity. Increased study of Polaris's fluctuations offers insight into the dynamics of binary star systems, as scientists track how the forces between stars in such systems can lead to dramatic shifts in their behavior. Studying such systems also aids in understanding broader astrophysical principles, such as the life cycle of stars, the formation of stellar systems, and the impact these systems have on the larger universe. Supernovae, the explosive end of stars like Polaris, play a crucial role in the universe, contributing to the formation of heavy elements such as oxygen, nitrogen, and carbon. These elements are essential for life as we know it and are forged during the violent explosions of dying stars. By analyzing supernovae, astronomers can further understand the origins of heavy elements and how they spread throughout the universe, enriching interstellar clouds of gas, which can eventually lead to the birth of new stars and planetary systems. The study of supernovae has also been instrumental in shaping our understanding of the cosmos. These massive explosions are used as standard candles to measure astronomical distances, offering insights into the structure and expansion of the universe. Supernovae are particularly helpful in revealing the nature of dark energy, a mysterious force believed to be driving the accelerated expansion of the universe. As we consider the potential transformation of Polaris into a supernova, we are reminded of the vast and ever-changing nature of the universe. Polaris's eventual explosion will not only have scientific implications, expanding our knowledge of star evolution, but also cultural and symbolic significance. This event will provide a rare opportunity for scientists to observe a dying star's final moments, shedding light on the internal mechanisms of stars nearing the end of their lives. The transformation of Polaris will also serve as a reminder of the impermanence of the universe itself. Beyond its scientific implications, the eventual loss of Polaris from our night sky will likely reignite public interest in the cosmos, particularly among those who have looked to the North Star for guidance for generations. Its potential transformation into a supernova offers a glimpse into a rare and fascinating celestial phenomenon. As this event unfolds, astronomers will gain valuable data that can reshape our understanding of stellar evolution and the broader workings of the universe. In conclusion, while technological advancements have minimized our reliance on celestial navigation, the symbolic loss of Polaris would be profound. It marks the end of an era where this steady star acted as a celestial guide, and it underscores the ever-changing and dynamic nature of the universe. The eventual supernova of Polaris may be distant in both time and space, but its impact will be felt across the scientific community and beyond, providing insights into the nature of stars, their explosive ends, and the future of stellar systems. As we move forward in contemplating the eventual transformation of Polaris, we recognize that the study of its evolution is not just about understanding the star itself, but also about gaining insights into the larger processes that govern stellar life cycles. This research serves as a window into the workings of binary star systems, where the gravitational interactions between paired stars shape their destinies. Through the observation of Polaris, we can learn more about how massive stars behave when they are nearing the end of their lifespan, and how the energy from these stars will ultimately contribute to the cosmic environment. One of the most significant aspects of studying stars like Polaris is the way these stars can serve as laboratories for understanding the forces that drive stellar evolution. The fluctuations in the star's brightness and the patterns of its pulsations provide astronomers with invaluable data that can help refine theoretical models about how stars transition from stable burning phases to explosive deaths. These insights help us build a better understanding of how and why stars undergo these transformations, and they shed light on the conditions that lead to the violent events we call supernovae. Moreover, the potential explosion of Polaris is not just a fascinating event for scientists, but it also has deep implications for humanity's broader understanding of its place in the universe. The symbolism tied to Polaris as a guiding light has been an anchor for human culture, representing hope, direction, and constancy. Its potential loss will be an emotional reminder of how little we truly understand about the long-term changes in the universe, and how everything, even the most steadfast stars, is subject to the forces of time and change. In fact, one of the more poignant aspects of the impending change of Polaris is the emotional and philosophical impact it will have on us as individuals and as a species. This star has been a constant presence in the night sky for countless generations, offering a sense of stability and guidance to those who've looked to it for direction. To lose this fixed point will remind us that the universe is not static, and that our place in the grand cosmic scheme is fleeting and ever-changing. As we observe this dramatic transformation, we will not only witness a star's death, but also reflect on our own understanding of time, existence, and the uncharted paths that lay ahead for our species. As scientists continue to monitor the changes in Polaris's pulsations and its overall behavior, they will have the rare opportunity to track the final stages of a star's life. These observations will not only contribute to refining models of stellar life cycles, but will also help answer fundamental questions about the physics of dying stars and their eventual explosions. By studying Polaris, astronomers can gain insights into the intense gravitational processes that occur just before a star becomes a supernova, a phenomenon that is still not fully understood. At the same time, the eventual supernova of Polaris could have far-reaching consequences for nearby stellar systems, particularly those that are in close proximity to this massive star. The explosion of Polaris will release enormous amounts of energy, and the shockwaves produced by such an event could trigger the formation of new stars, planets, and potentially even life in the future. In this way, the death of one star may sow the seeds for the birth of others, continuing the cosmic cycle of birth, death, and rebirth that characterizes the universe. The repercussions of Polaris's transformation are not only astronomical but also deeply philosophical. The star's impending end forces us to consider our own place within the vast expanse of time and space. It underscores the transient nature of everything, reminding us that even the most enduring symbols of stability in our lives, like the North Star, are subject to the inevitability of change. This realization, though sobering, also serves as a call to action, to continue exploring, learning, and striving to better understand the cosmos that surrounds us. For astronomers, the event of Polaris's transformation offers a unique opportunity to gather data that will enhance our understanding of star systems, supernovae, and stellar evolution. By studying the behavior of stars such as Polaris, scientists are able to refine their understanding of the underlying processes that govern the birth, life, and death of stars. This research also helps improve our understanding of the forces that shape galaxies and how the elements necessary for life are distributed throughout the universe. Additionally, the study of supernovae is crucial in helping us understand the broader questions about the structure of the universe. Supernovae not only provide information about the physical properties of stars but also play a central role in measuring the vast distances between galaxies, helping astronomers chart the expansion of the universe itself. These powerful explosions serve as cosmic markers that allow scientists to trace the movement of galaxies and map out the universe's evolution over billions of years. In considering the eventual transformation of Polaris into a supernova, we are forced to confront the cosmic scale of change. While this event will unfold over an immense period of time, its impact will be felt across astronomical communities, as well as among those who see the North Star as an enduring symbol of hope and guidance. The loss of Polaris will mark the end of an era in human cultural history, but it will also herald the beginning of a new phase of scientific discovery and cosmic understanding. The ultimate fate of Polaris, as it nears the end of its life and potentially transforms into a supernova, stands as a reminder of the continuous cycles that define the universe. Nothing, not even the most familiar stars, is exempt from this endless process of transformation. As we look toward the eventual loss of the North Star, we are reminded of the profound mystery that is the cosmos, an infinite, ever-evolving landscape that invites us to explore, to question, and to seek the answers to the profound questions that define our existence.